Different location, different island, been busy for quite a few months, hadn't gotten a chance doing some courses. So there's quite a gap between the last video and this one. What I'm gonna look at today, fortunately though, it is new island, it's a refurbishment project, so I can get some nice lights at least, couple of things that I can strip and have a look into. Um, things I would not normally get. This is a next step pool light. This is how the front of a pool light looks, but normally you don't have these bolts. Normally it's just a plastic piece. You can see the LEDs inside. It's pretty much very frosted, but you can see the LEDs inside. I've tested it, it's working. We'll do a little quick one on it. It's supposed to run on AC. I don't have AC. I have a DC small, one of those wall warts, small little power supplies. So it's a Next Step brand. I've never seen this one before. I've always used the Pente version of this. And amazingly, this is over 300 US, as is all pool lights, and that is why I'm amused. I want to take a look inside and see what the hell cost that much money. I'm of the view that this is really just a very limited market, and everybody's just marking up stupidly. There's really, in my opinion, no reason that something like this should cost 300 US plus. This is probably 350 or plus. If you look at it, it has UL ratings. We have 12 volts AC, right? And that's what normally typical. So it's an isolated transformer for a pool light, so you cannot get shock. 12 volts again, very low potential. So again, the potential to get shock is very low. And this is the XA 150-foot cord. They come in different lengths. The cord costs quite a bit actually. So the one I checked at 300 and something US was a 100-foot cord, I believe. So this is probably even 400 US plus. Looking at the construction, right? Or in a pool light, you normally put a 2-inch PVC, one like this. You put a 2-inch PVC fitting, just like you would do with a jet, and then you'd put a jet end on this, and you'd screw into this. This is 1.5 inch MPT threads. This looks like a sort of a silicone spacer, just to sort of keep it in the pipe relatively stable, although it doesn't really touch because that's where it screws in. Pente comes with a little flange in the back which helps you guide the cord, and it fits very snugly into the pipe. This again, I've never seen it with screws, but we'll try to take those out. I don't have my set with me here. Hopefully I can get a flathead to fit inside there and can't take that off. This is interesting. I've never seen anyone put a gland on a pool light. Normally it's just epoxied in the end, right? This appears to be a silicone. It's moving slightly with my finger. Hopefully I can just cut this open. If I can't, I'll have to get a hacksaw blade. Again, different country, nothing really at all. No any of tools, barely anything. But I'll try to cut this open from this end and pull it out this way if that works. One way or the other, if I'm to cut this is plastic. I'm going to cut it. We're going to see inside this. I want to see what cost this money. Why is it that something like this is that expensive? It runs on AC. They don't do DC. Not sure why. And this is a multicolor light. If you switch it on and off, it's similar to the Pente. You switch it on and off, you'll get it change from one color to the next color to the next color. So what I'm going to do is try to do that and show that the light is in fact working. But I don't have AC, it's DC, so it will not function right. I'll have to just touch it and just show that it works, and then we will essentially try to switch out the different colors and then try to open it. Probably going to get destroyed by the end of the process, but either which way, all of these lights are going to get stripped out and thrown away. Well, as you can expect, American wiring, white and black. That's live, that's neutral, but technically because it's AC there already isn't very much of a live and neutral. They've got this cordage in here, I guess, to help the wires pack the space and have the wires going, I assume, and then there's a sleeve in there. This whole thing will be one continuous wire, no joints. The joint will be made at a junction box. Right, so let me try to get the wires connected up and touch it quickly and show that the light works. Okay, so the light is ready to be powered now. Let me just try touching it, and if you look, you can see we're getting the color. We're getting magenta. If I touch it direct, it comes off. It doesn't work properly. It's meant to work on AC as I mentioned previously. Let me see if I can switch it from magenta. It doesn't seem to want to switch. Before it was working on green. Again, with AC this would normally switch, but by just flicking it on and off very rapidly, but I guess it doesn't work very well with DC. Well, anyway, it is definitely a multicolor light and definitely adjustable. So the color, end color that goes, you can get it normally to change for itself, transition normally. I will check the spec of this one. Penta does the transitions through a controller. It does straight colors. It also does white, obviously. I'm unable to actually get it to switch color at this point. Let me open it up. Let's get to seeing what's inside. Initially, I tried to cut here, and I was hoping that this was just an epoxy plug and I would have been able to bend it and break that off. That didn't work out, so I eventually ended up cutting down here through the center, and as it turns out, it's not an epoxy plug. It was looking grey with the sticker there, and the glue on didn't take that off. It wasn't quite clear that this was just really a grey plug with two contacts in there, so you just push in and you get the contacts forming. Obviously it's keyed, so it goes in one way. While this is theoretically a very easy cut, be amazed when you have no tools. This is the best tool I have. This is what I was able to get, scavenge and use. Lots of fun trying to cut with this. Quick look now at the board. Again, the plug we talked about that was going to fit into there. Little piece here that would key into that, so you would basically have the polarity correct. And I haven't looked at anything at all really in any level of detail. It does look like it's conformally coated. I'm seeing a shine, an extra shine. Two capacitors, again smaller if you do two individual capacitors. Those look like 4 diodes, so bridge rectifier. I'm not sure why it doesn't work with the DC signal then, but it does say AC here. It does clearly state AC. It should theoretically work with DC. This looks like quite possibly 3 LED drivers, inductors to go with them. So it's interesting how they've done that. I haven't checked to see what that is. This chip, not sure what that is. Clearly they've left a space for a small micro to be able to do some sort of conditioning, lighting, maybe changing. It says U2, so, and this says U1. So yeah, this is some micro also, and then this is probably a little bit more complicated, being able to do some functionality. I don't know, maybe it has some memory capacity to allow it to recall scenes. So the other side of the board is unpopulated. They've stuck in some silica gel. That clearly hasn't helped. It's gotten some moisture in. Small amount. You can see some small corrosion. You can see corrosion here and on this screw there. Not quite sure what the purpose of this strap is apart from keeping this stiff. It doesn't look like it's any use heatsink wise. This is obviously the heatsink. Clearly we can see blue negative, blue positive, green negative, green positive, and then red positive negative. So they've done the red this way, strange, and they've crossed these over this way. Whatever the reasoning, it goes across. The LEDs in front now, right? You have 3 LEDs, obviously green, blue, red, and they've left space to populate 1, 2, 3 more. So there's space for 6 LEDs at maximum, which again will possibly be the same again, green, blue, red. So they've labeled it red, blue, and where's the green? Oh, green. Those are the contacts. This is a straight board on here. It may be an aluminum type board so that you get the heat sink. These LEDs look like they have their own integral lens to focus. I'm not sure if they have the integral resistors, but I'm seeing 3 resistors here. 1, 2, 3. Not sure if those are for those or for the LED or for even both. So looking at this as a whole, bland piece of plastic, plug in very thin tube that's flexible, a fitting at the end bonded with epoxy, a front piece that's clear plastic and has 2, 4, 6, 8 screws holding it. A piece of aluminum with mills on the sides. Drill and tap holes to accept these 3 screws. A drill and tap hole in the back here to accept that screw. A very simple single-sided board. Well, it's 2 boards, but it's only populated on one side. It's double-sided board technically, but only populated on one side. Rather small board, didn't even have a proper connector. This is just solder. Simple drivers, simple controller. There is no way, there's absolutely no way this should be selling for over $300. I'll check the price, I'll stick it in the bottom of the video, but there's absolutely no way. The pool manufacturers, the pool light manufacturers they're really abusing the situation simply because there are a few manufacturers on the market, supply and demand. They are charging prices that are exorbitant, that they are probably making. I mean, if this is mass produced especially, they're probably making 95% profit, 90% profit. So I've satisfied my curiosity with respect to that. I believe it's price gouging. As predicted, that chip was in fact an LED driver, AL8806. It's a DC-DC converter to drive the LEDs at constant current. It's now been superseded at 8860 or 8861. This light is probably about 10 years, probably plus old. These chips run from 6 to 36 volts, so the 12 volts is perfectly fine. And then they switch in frequencies up to 1 megahertz. The typical diagram, as you can see, it shows AC coming in, bridge rectification, and it shows the inductor. So that is definitely a recommendation from the manufacturer. This is a functional block diagram, not going to get into that too much. And then moving on, the other chip, which is projected to be a controller, is in fact a PIC microcontroller. It was a bit difficult getting all this information off of the conformal coating, pretty much obscuring the view of the numbers. And then this is a basic diagram of the PIC. It's a 8-pin. The PIC microcontroller is fairly complex. There's a lot of things that could be done in that, so I'm just gonna leave it as that.